Hi guys, let's start with the homework. Alright, the hint is the relative masses of ethyl amine is 45 and for hydrochloric acid HCl is 36.5. Ethyl amine and hydrogen chloride react together to form a white solid, at which position in the tube would a ring of solid and white ethylamine hydrochloric acid form? Well, the idea is these two gases will start traveling to the center, towards the center, right? And whichever one's the heaviest or the heavier one will travel less. So let's identify the heavier one. That's ethyl amine. So by the time it travels to, let's say, A, hydrochloric acid will reach A as well, because the hydrochloric acid is much faster. So C and D are already out because it can be closer. B is the dead center, so it won't be at the center either. So A is the only viable option, which is closer to ethylamine than the rest, right? So your answer is A. All right, let's move on to the next question. Gases can diffuse through porous spots. The diagram shows the beaker full of nitrogen inverted over a porous spot containing carbon monoxide. Now, a lot of people had issues with this question. So you have nitrogen, which is N2, right? It's N2. And carbon monoxide is carbon and oxygen. And let's take a look at the options. So water level does not move. Which statement explains this? Nitrogen is almost inert. Well, inert means it's not reacting. We don't really talk about what's reacting and what isn't so far. So this is kind of like, if you have doubts, you can mark it as a, well, I don't know so far. Maybe it could be the right answer. Maybe it's not. Let's see. The two gases have equal molecular mass. Is that true or not? But if we look at the case we studied last time in class, a very similar diagram where the water level wasn't changing, that was because, let me scroll back. That was because what ends up happening is if the gas inside the pot can diffuse faster than the gas on the outside can diffuse in, so that ends up leaving a vacuum and the water level ends up changing. So it's a, one of the bigger hints is that we mostly talk about diffusion when it comes to these things. So nothing else is being discussed. So that narrows out what they're trying to ask, and also that we've done a very similar question. Okay. So the question is about the rate at which the two gases are diffusing. Now, why are they diffusing? Now, we don't know their masses. I haven't even given a hint for it. But what else could affect the mass, the diffusion rate, if not the mass? So there's temperature, and what's the third thing? If I remember correctly, it was the concentration difference, concentration gradient. So three things affect diffusion rate or rate of diffusion. So there's no mention of temperature here. Both gases are at the same temperature, so that's logged out. So if they have similar masses, that means they're not diffusing in, and like not one gas on the inside is not diffusing faster to the outside than whatever from the outside can come in, right? So that's more like a solid answer at this point. Let's go back to the options and check the other ones. So I'm very positive with this one. Okay? Both gases have two atoms in a molecule. Now, this is kind of an issue for people trying to do MCQs for the first time. This fact is correct. This is a correct statement. But does it have anything to do with diffusion? Did we ever talk about diatomic molecules or single atoms? Sure, they're larger, you can argue that, but we never brought their particular size in our talks about diffusion. So their size or the diatomic or single atomic or polyatomic doesn't really matter, right? So even though the statement is true that both gases have two atoms per thing, because it's N2 and CO, this answer, this part C, has nothing to do with the question being discussed. Okay, so even though it's true, we're not discussing it. So that's something you got to look out for. So C is correct, but not relevant And you'll see a lot of these type of options. Neither gas is soluble in water. Well, that's kind of true as well. But again, doesn't really affect our answer. Or it might not be true. I'm not really sure. I think they're not soluble. Neither are soluble. Okay. So the two gases have equal molecular mass. That means their diffusion rate is relatively the same. So the gas on the inside never ends up diffusing faster relative to the whatever gas is on the outside. Okay. So the answer for this is B. Let's move on. Now I kind of like these questions because they confuse you the first time, but if you're kind of quick with your, I don't know, if you can filter information out really quickly, it becomes a lot easier. So let's read the question first and I'll show you what I mean. Which row shows correct statements about the speed at which a gas diffuses? Effect on molecular mass. Okay. Let's just focus on this. So higher molecular mass diffuses faster. Well, no, that's the exact opposite. So these two are statements that are wrong. So I'll cancel them out, right? I'll cancel them out more neatly. Okay. And the other two are correct, so I won't touch them. Anyway, effect on temperature. Diffusion is faster at higher temperature. Well, this is correct. So the lower ones, they're the exact same statements, they're wrong. Right? So this is wrong, this is wrong. And look what ends up happening. Look what's going on. Why am I talking like that? So over here, both are true. So I don't even have to bother with the question too much when I start filtering it out, right? So C is the correct answer because I just removed all possibilities of like the wrong answer, right? So this is a way you end up doing your questions, your MCQs faster or more confidently just by ruling out other possibilities. Also, this could have indicated, like this could have helped this statement here for the previous question. So some questions end up helping you for other questions that are present. So if you're unsure about a question, don't commit to it. Put a question mark like I did for question number 2. And when you read this, you should be more confident, like it should be in your head. Oh, didn't I do a similar question where, I didn't think of the mass even though the mass was present about diffusion? Let's go reread that question. And because this was homework, you had a lot of time. So yeah, I'm just saying pick up hints from the question paper as well. That's a viable option. Let's move on. So methane is CH4. I think a lot of people who got this answer right. And butane is C4H10, right? Ended up Googling the MR for methane and butane. I think I'm at fault where I didn't really highlight their respective MRs. Oh, I don't think you need the respective MRs because it says both gases are released at the same time. The methane gas reaches the flame and catches fire before the butane gas does. Okay, so you don't need to predict which goes there. They're already telling you methane goes there first. And it kind of makes sense with their chemical formula in front of us, right? Why has methane reached there first? So obviously because it's lighter. Let's see what the options are. Each methane molecule has a higher proportion of hydrogen than each butane molecule. That might be true. It looks like it is. But what would that affect on its speed? Why does hydrogen make it travel faster? Or I don't know. So A is just a fact, so to speak, with no real credit to it. Methane does not have isomers. Butane does have isomers. Those of you who know what isomers are probably think this is extra trash as well. Butane does have isomers where methane does not. But you don't need to know what isomer means. It's just that we haven't talked about isomers at all. So maybe it has nothing to do with it, right? So it's that part where, yeah, it has nothing to do with the question. So you'll see some fancy words lying around, especially in the assignments, because I'll give you more questions which are related to things, and they might discuss some things which haven't been discussed. Just so you guys know, you're more familiar with the exam paper, and just that you're more ready for words which are not, you haven't read recently, or by the time you're doing the paper, maybe you forget something about like some little information. So you know how to solve a question just by ruling out, hey, I don't know what isomers are, but diffusion I know never had an isomer in it. So maybe B is kind of like true or not true, doesn't really matter, but I'm not too happy with this statement. I don't want to answer this, right? And that's the instinct I want to develop by throwing this question in. Okay. Methane has a higher boiling point than butane. That might be true, but again, boiling points in diffusion. Methane molecules have a smaller mass, and that's the only thing that can talk about a higher diffusion rate, right? Otherwise, a temperature, but there's no temperature difference here. It's just a room with two gases in it, right? Yeah, so D is the option here. D. Let's move on. So a lot of people had problems with this question, and here's how you do it, right? You read each statement, and it's literally asking which is correct. So you read these three statements. Read these three statements individually, like on their own, and judge if they're correct or not. The volume of a gas at constant pressure increases as the temperature increases. Volume of a gas at constant pressure increases. Yeah, that makes more sense. If you heat up a balloon, it's gonna start growing in size, right? Like not directly open flame, but if you warm it up, it's gonna expand. It's more of a physics question at this point, but shows up in chemistry. And we did discuss these things in detail. So this is true. Rate of diffusion of a gas increases as temperature increases. I think I said that enough times today in this video. The pressure of a gas at constant volume decreases as temperature increases. Well, the pressure increases as temperature increases, right? More when you heat up a pressure cooker, by keeping the volume, pressure cooker is something that doesn't change in volume. So when you heat it up, the pressure rises because that's how it works. So number 3 is incorrect. It's a good way to kind of visualize, have examples ready for each case, right? And they're not too hard. I think we discussed exhaustively a lot of cases, and we randomly discussed different things. So visualizing a problem really gives you a good answer. Otherwise, you can rectify the logic and the relationship, but yeah, I mean, like under stress, you might mix it up, but whatever works for you. So we realize 1 and 2 are correct, and the only option highlighting 1 and 2 are correct is, or are, or is A. So the answer is A. All right, so I got 1 or 2 submissions of the homework where they had rewritten the question, and I think 1 or 2 kids had rewritten all the MCQs with the question, and if there was a table, they had drawn the table. As much as I appreciate your commitment, completely unnecessary. Please don't do that. It shouldn't take you too long. Just please don't do that. I feel so terrible for anyone who sent me that. When it was MCQs, you don't even need to explain it. Just answer A, B, C, D, right? Most of the kids did that. I'm happy. Just answers were A, B, C, or D. You don't have to explain it. You can ask questions about it if you don't understand it. That's fine. I understand that. But I don't need explanations. If you want to discuss it, that's a different thing. But I'm not expecting explanations as to why it's A, B, C, or D. Please do not rewrite the question again. Just something I do not want. I don't want to add unnecessary work to you guys for no reason. Just make sure your handwriting's neat, you're submitting it the right way, because it's easier for me to organize everything. A lot of people have also had trouble with that. But just please do not rewrite questions or any part. Don't do more work than necessary, but be presentable about it. Whatever you're working, don't be lazy like some kids just wrote it down on a torn piece of paper and just sent pictures, even though I asked for PDFs. Maybe they didn't know how to do it. That's understandable, but just don't overdo it either, right? Just the necessary amount of work is expected, whatever that is. Follow instructions. Don't do over, but also do not underdo it. Like, don't throw the assignment at me. Someone just replied, typing in the email all the answers and whatever. No, I can't check that and give it back to you. So that's a problem for me as well. Enough talk. Okay, what is meant by the term diffusion? So I had most of the people got this right because I practically told them everyone what to write. Now, some people had fancier words because they want to, I don't know, be different, have their answer stand out. I'm gonna say just play it safe, because some definitions, most definitions, if you understand a concept properly, you end up realizing that definition is essentially the best way of explaining it. So you don't have to memorize a definition, but once you understand a concept really well, that definition automatically comes out when someone asks you, hey, what is meant by X, Y, and Z, or whatever they're talking about. So that definition automatically forms, comes to your mouth, like you end up saying it, because that's the best way, like people thought about those definitions earlier, right? Okay. So that's why I'm encouraging this particular definition. Also, any examiner, don't give him a hard time, right? Like, because he's probably checking like 2,000 papers a day, right? So whatever he's looking for, just, give him that. Now, I also asked a lot of people to add, after this, lower concentration due to the random motion of particles, or Brownian motion, right? Now that part is not necessary. I want everyone to think like that. Diffusion is the movement of particles from a region of higher concentration to the region of lower concentration, because particles are moving randomly, and that's what ends up happening. But you don't have to write it. If you write it, good. If you don't, I'll never cut a mark for it, because I match my answers with the marking scheme. You can actually argue your answers if you think the marking scheme will mark it correct, so to speak, right? Let's move on to the next question. Explain why propane diffuses faster at 100 degrees Celsius than 60 degrees. 100 degrees, a lot of people got this right as well. It has more kinetic energy at a higher temperature, so it diffuses faster. Higher temperature means diffusion is faster. You didn't even have to mention kinetic energy. You could have said, at a higher temperature, gases will diffuse faster. And that's one of the 3 things affecting diffusion. Higher temperature, lower mass, and higher concentration gradient will allow gases or, solute and solvents to diffuse faster. Explain why diffusion could be used to separate a mixture of methane and propane. Now, I think 90% of people got this. I had weird answers. I kept hearing the word thermal diffusion. Thermal diffusion. Honestly, I didn't even remember what this was, diffusion. But everyone answered it, and not in this particular case, you can't use that. But the question, it was looking for was that to realize that methane, you should understand that methane is a lighter gas, and how would you know about it? Well, at this point, you shouldn't be able to know. But I think we've done a few questions related to methane and not propane really, but I liked how a lot of people ended up Googling methane and propane ka mass and ended up quoting that. And that's what I really appreciated, that extra work. Okay. So methane, you can collect it, because if you release the 2 gases, one will end up diffusing faster, and you can collect it and stop collecting when the propane shows up, then collect that separately. So that's the essential idea. You can use them to separate these gases, right? Like if they're mixed, one can diffuse faster, so one can be collected early on. Think of that tube which we were talking about in the first question, in the first MCQ. So a setup like that could be used, where one side you have a mixture and you let it go and you realize, okay, methane is gonna reach the end first. You can collect it, then later collect propane. Okay. Probably not the best way, but can work. The graph shows the heating curve of tungsten. Now the heating curve over here is highlighting that it's melting. It's gonna melt over here, and it's gonna boil over here. Okay. Let's move on. See if I can zoom and pan. Okay. Use the graph. I'll just try to show it. Use the graph to give the boiling point of tungsten. Well, actually, a lot of people ended up saying 6,600. Well, the graph is ascending this way. From the bottom, it's rising. So it's at 5,000. Over here, it's going to be 5,500. You can count each individual tiny square comes about is 100 degrees Celsius. So it's about 5,600. That's what I'll write. It's gonna be 5,600 degrees Celsius. And the next question you can't see yet. Let me just scroll. Predict the temperature when the tungsten wire breaks. When do you think the wire will break? I got a few confusing answers, so I kind of enjoyed that. So you people were trying to think, right? Well, look what's going on. The wire will break at 3,400 because it'll melt. Pighal jayegi, right? So before that, it's still a solid. So if you don't disturb it at all, but like it's gonna get weaker and weaker. But at this point, it's gonna turn into liquid. So that wire will literally melt and break off. So at this temperature, it'll break off. I got a few weird answers, which were like 7,000 or really high numbers. They were just asking. It's another way of asking when the wire will stop being a solid. It'll break because it stops being a solid. That's what it's trying to ask. So answer 3,400 degrees Celsius. ठीक है. So with the last question, I think everyone has had good training with this question to draw solid, liquid, and gases in terms of particles. No one got this wrong, so congratulations. A good solid 6 marks. Yeah, and that's it. So if you guys have any more questions, let me know. And good luck for your test.